Hey guys, welcome to the shop. I just seen a mouse. Today, we're going to be doing something a little different. We're not going to be machining anything, at least that I know of at this point. We're going to be repairing an item that has been annoying me and maybe some of you guys for quite a while. So, let me bring you over here, I'll show you what it is, and we'll get started. Alright, so back behind the shaper, back in the bowels of this machine, there is a rotary phase converter. Now this rotary phase converter costs more than the shaper. When I bought it, I needed something to power it. It's a three-phase machine. I don't have three-phase power here, and I didn't have much option. It worked great in the beginning. It was really super quiet, but now it's started to make some noise. So I'm going to turn it on. We'll see if we can get this thing to squeal, because that's what it does, and you'll see why I want to fix it. Hear the squeal? That's unacceptable. We're going to take this thing apart, see if we can fix it. And I hope we can, because this is annoying. Well, so far today, up to this point, I haven't felt like dying. This thing's still got power to it, so I'm going to go flip the breaker, check it 3 or 4 times just to make sure, because this stuff's dangerous. We'll get this thing unhooked and get it on the bench. All kinds of junk under there. Alright, now I have shut off every 220 lead that I have in this shop. I know which one this is, but just to be safe, I don't care if my air compressors kick on or not. It won't hurt anything to turn them off. So I turned off every 220 lead that I have in this shop. I am not an electrician, but I try to practice as safe as I can. So it doesn't hurt to turn off everything. It's just a little reassurance, and to double and triple check that you don't have power, because this stuff will kill you and you can't see it, and that's what makes it scary. Alright, I've learned several things over the years working on electronics and stuff from time to time. It's not my expertise, but I can do it. This works just fine. I wired it up in the beginning and I'm happy with it. I'm taking this stuff apart right now, but I'm not going to rely on my memory to get things back together, although I do have a wiring diagram and stuff that I keep on file. But I tape all my wires, and I even take a cell phone picture, a detailed picture, separating my wires where I can get a good clear shot. That way when this thing goes back together, it goes back together exactly the way it came apart. A little tape, a Sharpie, and a cell phone, and it'll save you a lot of grief. Alright, now this is an American Rotary 10 horsepower phase converter. It was a really pricey unit. I paid full price for it, way before I ever started, even considered doing YouTube. So, in the beginning, this thing was great. It was quiet. It worked just like it should. It really was a nice unit. The control panel, the push button turn on and off, not your just standard old plug-in type. It really is a nice unit, and it's a good motor. This is a ghost motor, which generates the phase that I'm missing, and it's a Gentech. That's good. That's fairly good quality stuff. So I was a bit surprised when it started squealing like that. Now, it started off slow. I contacted the manufacturer, American Rotary, and I actually contacted them a couple times. In the beginning, it was, give it some time, let us know. They were really nice. Then it started getting a lot louder, and they was like, well, you can send it back. Well, I don't want to box this thing up and send it back. I've gotten rid of all of the packing and everything. And for a guy like me, that's just not a good option, really. So I'm going to try to fix it myself, just like anybody else would do. I don't know what's wrong with this thing, but if I'm going to throw a guess out, and I'm going to say that it's some sort of shield or baffle that is maybe has a rivet or something come loose and vibrating. It's something simple because the unit really does work great. It just is noisy, and I can't handle that, especially filming. And so we're going to take this guy apart, and we're going to be real careful when we do it. We don't want to damage anything. We're going to go at it slow and methodical and try to fix this guy correctly the first time. Okay, now I have taken a lot of electric motors apart in my day, replacing bearings in the standard AC, replacing brushes in some of your DC motors. It's something that I do on a fairly regular basis, so I'm confident that I can take this apart and get it back together without damaging it. There are some things that you need to know, and that these are fragile, especially the windings in them. When you're putting the rotor in and out, you got to be real careful, because all it takes is one little slip and you ruin it. And the second that I crack one of these bolts, I understand that probably voids my warranty. So that's another thing to consider. I don't care, because I want this thing fixed today, and that's what we're going to attempt to do. So let's get this thing apart. Alright, mark this guy. It has marks on it, but I want to mark it just to, it's going to be hard to get it wrong, but if you were doing a motor that wasn't marked, you just want to get it back to the way that it was. And these are studs in this one. So, let's take these, pull them out. One end cap. Looks pretty good so far. And I don't really see anything on this side that will cause it to squeal. We've got some shielding there just to keep dirt and debris out, but I think we're going to probably find our problem on the other side, of course. Now, here's where you got to be really careful. All these windings, all it takes is a bump with this rotor getting it in and out to destroy this motor. So we need to be real careful. Here's something kind of neat. Let's see if I can get you over here and get you a good look at this. Here's how they balance this motor. And they've just used an epoxy. So there's your rotor, your stator, and that's how they balanced it. Pretty basic, but if it works, it works. This is magnet wire, which has each is shielded, and all it takes is for you to scuff one or two and then them short out, and then this is garbage. So we don't want to do that. I'm going to try to tap this other side off, and hopefully we find what's causing this vibration. Alright. Real careful. Alright, let's see, I think what's causing it. Real careful. Get this thing out of here without damaging anything. That fan's what's doing it, I guarantee it. Alright, let me get situated here, we'll get you a better look. Just a little dust. This is actually a pretty clean unit. It's been sitting on the floor, but I try not to get too much dirt around it. But it has to be this fan. I mean, there's nothing else in here to vibrate like that. So let's see if we can see anything that looks like it's been, you know, squealing or vibrating. Okay, I think I see why it may be, possibly. Let me get you a better angle. Okay, we got one weld here and one weld here. That's 2 points, and I would bet that this thing is, you know, getting harmonic and shimmying like this because it's got basically a point to pivot. That's just my opinion. You know, I don't know this for sure, but I think I'm going to take the TIG welder and put in just a little TIG weld here and one on the other side, and then we'll run this guy and we'll see if that does it. So let's take this out to the welding area and put a couple little zaps on this thing. Alright, now I've been looking at this thing for a few minutes, and what this is a laminated fan, really. It's 2 pieces of metal. They've sheared this and folded up the fins, and then to fill in this void they've spot welded another piece of metal to the back side of it. So this piece here is just a ring, and then this top part is the actual fan. So this presents a few problems in that everywhere these 2 pieces of metal come together, they can, you know, get harmonic and start chattering. And I think that's probably a lot of what we're hearing also. So if you can see, I got a little, I don't know if you can see it or not, hopefully you can, a little tack weld there that's burned through from the other side where it was welded. There's another one. And I'll probably come in from this top side because I got better access and tack it, you know, 90 degrees to both these welds here and here. Because I'm thinking maybe this fan is shimmying like this using these 2 welds as a hinge. That's my thought. So it's probably a combination of that and all these little areas where this ring here, this is 2 pieces, meets all these back, and all it is connected at these little spots here. So all these little ends here could be, you know, vibrating. Not probably the best design, but I'm no fan designer. I'm just some goof in the shop. So let's take this out there, see if we can get a couple spot welds on this, and hope it fixes it. When we ground to this thing with the welder, we want to make sure that we do not ground through a bearing. Grounding through a bearing is horrible. Like if you weld on, you know, a motor or something like that, you always want to ground to the part that you're welding. You want the shortest path possible. That's my opinion. You definitely don't want to ground through a bearing because then you'll have arcs through the bearing, it'll ruin it, and you'll have problems. So let's take this outside. Alright, so we're all set up. We've got our rotor on the bench. I've grounded to the fan. I'm going to TIG weld this guy. So We're just going to be using our cheap Harbor Freight welder. Work, I weld with the Dynasty 200, a Miller welder, and that'll spoil you quick. But to be honest, this little TIG welder, not that bad. It's done everything that I've wanted to do. It just lacks a lot of the advanced features of some of the nicer welders. One day. So I'm going to get you at a better angle, and we'll weld this guy. Just going to make sure that I got good room to get my torch in here. Do a dry run. One side. You don't want to add too much filler and throw this thing any off balance. Let's flip it around. Do the other side. Alright, now I've been thinking about this, and I've got my two little tack welds, one there and one there, and they look pretty good. And I think that if it was vibrating here, that would solve the issue. But I've got a sneaking suspicion that it's where all these little tabs, this is, like we talked about earlier, two pieces. So I am going to come in and I'm not going to add any filler material. I'm just going to bond each one of these little ends right out at the end. I'm just going to come around, tack, tack, and tack each one, because I don't want to have to take this thing apart again. I want to do it one time, and I'm going to try to do as thorough as I can, come up with a repair. And I believe that this will at least help, because there is a separation here, and that's plenty of room for these little things to squeal like they are. So that's what I'm going to do. I'm going to tack each one and hope that fixes it. I'm not going to be adding any filler material. All I'm going to be doing is bonding these two pieces of metal together so I don't affect the balance of this motor much. Alright, so in order to get this thing back together without damaging it, because this is the most critical part in my opinion, I've kind of thought about this, and I put on the first cap. I just stuck it on there that I took off, and I'm going to set it up on its end and then lower the rotor down in to the housing so I don't bump it around onto the windings or the stator. Set it up on its end like that. Let me get you in while we got some good light and show you the repairs that I did. Alright, there we go. We just zapped each one right at the at those tips. Now it's still possible it could squeal back here, but you know, we're going to take our chances. We tack welded there and there to go along with the other two. So now hopefully this thing is more rigid. We didn't add any filler metal out here to affect the balance really, so should be fine. So let's get this thing back together and try it out. There we go. There's that. Back end cap on. There we go. Our studs in. Tighten her back up and reinstall it. Hope that fixed this guy. We're soon to find out. I don't see why it shouldn't. Because there wasn't anything else in there to be vibrating like that. So. This guy's sealed up, safe. We'll go flip our breaker back on. And we'll try it. Alright, moment of truth. I sure hope this works. That's what it sounded like when I first got it, and I'm happy about that. Now it always done it worse when I turned it off, so let's see if when it's spooling down it's quiet. Yeah, good deal. Well, this is a big deal for me. I don't know how much film that I've had to just, not show you guys simply because this thing starts squealing and it's obnoxious. Not only do I not want to hear it, I don't want you to have to hear it. So, I'm glad I got it repaired. I'm glad I brought you along. I really appreciate it. If you like this video, guys, give me a thumbs up. If you haven't, make sure to subscribe to the channel by clicking on my little guy up here and hit the bell for notifications. And as always, I'll see you next time.